All right. Part A. We're just going to put it in an exponential. Don't stress out about this. This doesn't come until part C. I'll stress you out again in part C. No stressing out, though, until part C. So everybody put your smile back on. All right. Mary, what's the index in this problem?
6.
Very good. What's the radicand?
5. A.
A. And what's the exponent?
5.
5. Very good. They probably thought the same thing. Okay, part B. Mary, what is the only thing in this problem that has an exponent?
The X.
The X. Did you hear that, guys? Only the X has an exponent. Look at problem 2, part A, if you need some further clarification. So, Mary, does the 5 go inside the radical sign?
No.
No, the 5 chill... Ooh, that was ugly. The 5 chills out outside, and there's your radical sign. Mary, what do you think the index is?
X.
X is the radicand.
Oh, I'm sorry. 3.
Oh, I forgive you. 3 is the index. Mary, what's the exponent?
1.
1. Now, guys, we're not going to write an exponent of 1 because it's always implied. All right, now part C. Time to stress out again in part C, okay, everybody? First step is to write it like our first step up here in part B. So, Mary, do you think that you'll be able to split it up and give each one that exponent for me?
Sure. 54 to the 2/3.
Good.
Y to the 2/3.
All right, I'm going to ask you guys the same set of questions we did up here, but I won't write everything out, okay? Mary, what is the index? That's the first thing to notice about this problem.
3.
The index would be 3. Very good. Because the index is 3, Mary, do you think I'm going to look at my perfect square list or my perfect cube list?
Cube.
Cube, because 3 is a cube. So I'm going to look at the cube list. Again, I don't have mine because I left it at school, and I'm actually at my parents' house right now. I left it at school, but you guys have your perfect cube list. What is the biggest perfect cube that goes into 54? Well, when you're looking at your cube list, guys, you better see 2 cubed is 8. Nope, 8 does not go into 54. And then you should think to yourself, well, 3 cubed is 27. Does 27 go into 54, Mary?
Yes.
Yes. How many times does 27 go into 54?
2.
That is correct. Now we're going to rewrite this, guys. 27 is a perfect cube. You might want to just go ahead and put 27 with a star because 27 is a perfect cube that goes into 54. It's a lot of talking. Ready? So we write 27 times, what was it? 27 times what, Mary, makes 54?
2.
2. And the reason we pick 27 is because it's a cube. The reason we pick a cube is because... Sorry, my parents have dogs. Okay, the reason we pick 27, it's a cube. And the reason we pick a cube is because it was an index of 3. And again, 27 times 2 makes our 54 that we needed. Okay? Now, each of these is going to get this power up here. So, Mary, each of these gets what power?
2/3.
Good. And then the variable just kind of like, bloop, bloop, bloop. He's just kind of chilling out. He's coming down, okay? Do you see these two over here? Mary, just like up here, 2 the 4/5 and A the 4/5, where do they go? Inside or outside?
Inside.
And so does 2 and Y. Now I gotta ask Mary. Mary, what's the index of this problem?
3.
That is correct. What does each inside what is the exponent of the things inside?
2.
2 and 2. Give them both to them. Sorry guys, that 2 looks like a Z. Let's fix that so it doesn't look like a Z. There you go. Now we're going to put what number on the outside. I got to erase this because I'm running out of room. Well, if you don't know what 27 to the 2/3 is, you got to put it on your calculator. So grab your calculator, put 27 to the 2/3, and you get a 9. There's the dogs again. So a big fat 9 goes on the outside because 27 to the 2/3, boom, 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 makes what, Mary?
9.
9. Whew, now that is a reduced radical form. Hope you had a lot of fun with that. Okay, as we move on, what we're going to do is just compare the directions so you make sure you know what's going on. We did the very difficult part here. Converting to radical form is very difficult, guys. Now, I think, that's not wood, but I think you guys are going to like this part better, converting to exponential form. So instead of exponential to radical, this time we're going from radical to exponential. It's like a back and forth, a give and take. You love it, right? Problem 3, part A. Now, Mary, what is the radicand on part A?
3.
B is the radicand. What is the index?
5.
5. And that's the what? Numerator or denominator?
Denominator.
Very good. And what is the exponent?
3.
3. And guys, that's all there is to this one. That's done. Whew. You're like, oh, that's a load off. Well, that's because that's an easy problem. All right, let's step it up. Mary, what is the radicand? The entire radicand. What's the entire radicand?
27 to the
Go ahead.
to the first power.
Do you guys see how she just did that? 27 has a power of 1. It does not have a power of what, Mary?
5.
And many, many, many people think 27 has a power of 5, but that's not in parentheses, so 27 only has an exponent of 1. What does D have a power of, Mary?
D's got a power of 5/3.
It will have, yes, it currently has a power of 5, but Mary is saying 5/3. Now, why would you say 5/3, Mary? 3 is the?
Index.
That's right. And we just have to also give that to the 27. So the 27 gets a 3, and the D gets the third, I should say. And that came from the what, Mary?
Index.
Index. Now, we never leave this alone. But here's the good news, guys. Go to your index is a 3, right? Do you know what list we're going to look at? Would it be squares,
Your
cubes?
cubes.
Yeah, your cube list. You're going to look at your cube list again, everybody. Now, here's the good news. When you go to your cube list, again, we're going to the cube list because your index is a 3. When you go to your cube list, you're going to see 27 is on there, and you're going to go, yay, right? Maybe you won't, but you should, because the cube root of 27 is simply
3.
yeah, a 3. Good job, Mary. And then that's D to the 5/3. Now, if you don't believe me that that's a 3, type it in your handy dandy. Okay? The cube root, or 27 to the 1/3, is a 3. So we are practicing how to go into exponential form from radicals. We will touch on this, if you can believe me, we're going to touch on this even heavier when it comes into Algebra 2. Please still take Algebra 2. Okay, Part A. Yeah, go ahead. Part A, we are just going to rewrite it in exponential form. Mary, what do you think this is going to be in exponential form?
S to the 2/3.
That is correct. That's all we need to do, everybody. We don't have to bother with any of that. It's just S to the 2/3. Now, in Part B, Mary, what is not inside the radical sign?
The 12.
The 12. And he just kind of chills out, guys. He doesn't have an exponent. I guess technically he has an exponent of 1, but we never write that if we don't need to. And then we have that x. Mary, do you know what the exponent of the x is going to be?
4/3.
That's perfect, and that's all she had to do. It's all simplified. We don't have to rewrite anything because 12 doesn't have an exponent. Oh, but Part C. Okay? In Part C, do you see... Part C, do you see... I'm going to say it again. In Part C, do you see the parentheses? I hope so, because you should remember from Section 7.3 that 5 needs to go to the 4. And it also needs to go to the y. The 5 applies to both of them. Okay? So when we rewrite this, we are going to rewrite it with 4 to the 5th and y to the 5th, but they both need a denominator.
2.
Yes, why is it 2, Mary? Where the heck do you see a 2?
It's assumed. It's implied.
That is correct. It is implied. Remember how we talked about it, guys? If there's nothing there, it's implied. All right, yay, go us.
Woohoo.
All right, now y to the 5/2, that's not changing. Leave it alone. It's y to the 5/2. It looks like an S. Now, what list would you look at? Would you look at your perfect fifth list or your perfect square list?
Square.
You would definitely look at your perfect square list. And here's the good news, guys. You know 4 is a perfect square, right?
2.
Yeah. So essentially what's going to happen, if you can follow this, if you can't, just type it in your handy dandy. Watch what I'm going to do. I'm going to ask Mary questions. You pay attention. Mary, what is the square root of 4?
2.
And what is 2 times 2 times 2 times 2 times 2?
32.
That is correct. So this is going to be 32, but let's say you're like, what just happened? Grab a calculator. I'll make you do this in Algebra 2 the long way, so you may as well replay the video if you didn't understand that. Or just wait till Algebra 2. 4 to the 5/2 is 32. Last one. Mary, what is the power of 256 inside right now?
1.
That is correct. And it is not what, Mary?
8.
Nobody make that mistake when it comes to a quiz or your homework, okay? 256 is a power of 1. Mary, this is going to be 256 to the what power when I include the index? It's going to be
1/4.
That is correct. Now you got the 4 from the index, right?
Oh yeah.
Yeah. And this is going to be a to the, I know you might want to reduce that right away, but go ahead and tell them it's going to be
8/4.
8/4. Now, did you guys hear me say I'm going to make her reduce that, right? You guys never, ever, 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 ever leave fractions that don't reduce. Mary, what's 8/4?
2.
Good. So this is really just a squared, everybody, because 8/4 is 2. Now, Mary, we have a 1 and a 4. Do you think we're going to look at our perfect 1 list?
No.
We don't even have one, do we? A perfect 4th list. Well, I think that 256 is on your 4th list. Mary, what do you know what 256 to the 1/4 is?
4.
That is correct. Now, if you guys don't believe us, by the way, that's because 4 times 4 times 4 times 4 is 256. But let's say you don't have those memorized. Pretend you haven't been teaching algebra for, I'm not even telling you because that's going to make me sound like a long time. 4, right? After a while, guys, these are just going to become familiar. You're going to memorize a few of them. Okay, I've had 8 years. 7 years. Not 8. Okay, that's very quick. Oh, yippee skippy, we have a word problem, your favorite. You can estimate the metabolic rate of living organisms based on a body's mass using Kleber's law. That's right, thanks, Mary. The formula R equals 73.3 times the 4th root of m cubed relates the metabolic rate R measured in calories per day. Wow, this is a long problem. Measured in calories today to a body's mass m measured in kilograms. What is the metabolic rate of a dog with a body of 18 kilograms? So you guys can do this problem like even with yourself. If you know how many pounds you weigh, you have the capability of going online and figuring out how many kilograms you weigh, and you can plug that in yourself. How nifty is that? All right, so they're asking what the metabolic rate is. Mary, what is the variable that stands for metabolic rate?
R.
Good. So when they say what is the metabolic rate, we do R equals, well, what's the coefficient that they have here, Mary?
73.3.
That's right. She's just following the formula. Now, guys, please, when you see a word problem, look for a formula. Don't stress out right away that you see words. Look for a formula. Try to figure out where you can plug things in. A lot of you see a word problem and you just stop. You can do this. All right, Mary, what root do they want us to use?
The 4th root.
The 4th root. Very good. And this is about a dog, and M stands for what in this problem?
Body mass.
Body mass. Very good. And what is this dog's body mass?
18 kilograms.
That's right. And what power is that to?
That is going to be to the 3rd power.
And where'd you get that from?
The formula.
That's because when you go to a word problem, you're not going to freak out. That's right. Just go to your formula and you find it. You can do this, everybody. Now here's the thing. When you look at your calculator, you do have a square root button. But unfortunately, unless you know how to manipulate your calculator, which I'm not going to teach you because I'm mean, you have to change this to exponential form because you don't know how to type the 4th root in your calculator. Look, you can hopefully all type the square root, but there's no little 4 inside of there unless you're really clever and you've played with your calculator when I wasn't looking. You don't know how to do that yet. So we're going to rewrite this as 73 to the 3rd, or 73.3 times, Mary, what goes in parentheses?
18.
18. And you don't, guys, you don't have to use parentheses. I don't know. It's just a habit for me. You don't have to. Okay, if you don't want them, just do times 18. Mary, what's the exponent?
3
Over
4.
See how she learned that lesson so well, everybody. I hope you did too. 3 from the exponent, 4 from the index. Now watch how nifty this will be. 73.3 times 18 to the... Remember, I have to use parentheses. If you're using your cell phone or whatever, you're going to have to use parentheses too. Remember, we talked about how to do this in class. 640 point... Let's just round to 6. 640.6. Now, what in the world does that mean? 640 what?
Calories per day.
And all she did, guys, is she read that. That's what a metabolic rate is. Now, what that means is that dog is allowed to have, to meet its body mass, that dog's allowed to have 640.6 calories per day. That's not too bad for a dog. Now, what is 18 kilograms? I don't know. But you know what we should do? bonus. You guys are going to love this. I just said the B word in math. Bonus, that's right.
Woohoo.
If you guys, and you don't have to do how much you weigh if that's you're self-conscious about that, that's cool. But if you guys want to write down a weight, like I'm 130, why doesn't somebody find mine or find your own? You can write down your weight, convert it to kilograms, and then tell me what your metabolic rate is. Put this on a separate sheet of paper, otherwise I'm not going to take it. Put it on a separate piece of paper, write bonus on the top, say this is how much I weigh, or this is how much Susie Q weighs. Change it to kilograms. Give me that metabolic rate. That'll be kind of fun for you to do a little bit on the side here. Oh, my brother's here. Adam, say hi.
Hello.
If you guys ever meet him, you cannot call him Adam. You will call him Mr. Failert. Hence, my sister-in-law is Mrs. Failert. Okay. Sorry, my brother's being a brother. All right. We're going to do this with a man now with oh my gosh, I can't say it.
Body mass index.
Thank you. He's got a body mass of 75 kilograms. Now, you know what? I got to Google this. You guys just hold tight real fast. I want to figure out how many kilograms this is. Why don't you guys take the time, set up the equation. You can do that, right? R equals, okay, you go. You do your R equals while I Google. Don't worry, I'm real fast. I hope you have R equals 73.3, right? Because we got the formula from the other sheet. 4th root of, okay. How many kilograms? 75 kilograms to pounds. This is for, I just Googled it, whether you trust me or not. This is for a 165-pound man. That's what, okay? So think of somebody that's like 165. That's like my husband. And some of you know my husband, that real tall, skinny guy who used to substitute. That's like my husband, 165, okay? But we're doing it in kilograms. Mary, do you remember what big number goes inside?
75.
And do you remember what the exponent is?
3.
That's right. And Mary, unless my students cheated with their calculator, they don't know how to do the square root, the 4th root of something. So how are they going to type this in their calculator?
73.3
Times
75 to the 3/4.
And I'm not going to be mean and make them go and reduce all that stuff. Since it's a word problem, they should be happy they can use their calculator. Instead of 18 like last time, though, this time the man is
75.
And how many pounds is that, Mary? Do you remember?
165 pounds.
And so let's see. If you are a 165 teenager, you're probably going to need more calories in this because you're still probably growing. But, wow, how lucky is that? 1,868 calories. Let's just stop there. We'll do a squeakle, so that'll be exciting. Ready? Oh, squeakles. 1868 calories per day. And guys, that's without any that's not without him doing anything extra. You know, if he exercises or even walks around or he moves a lot on his job, he better be eating way more than that. That's just how much his body naturally burns in a day. If you guys have ever kept track of calories, 1,800, man, that goes pretty fast, okay? If you were confused, let me tell you a real good problem for you to try and come back to me, and that would be number 7 and number 6. Those would be really good problems for you to try and come back to me and check your answers tomorrow in class. Have a good night. I can't find the stop button. I bet you guys are laughing at home. Okay, bye-bye.